finding components and projections, the PROJ projection. If you have 2, 1, so that's your vector u. Okay, and then vector v is 1, 2, 3, -3, and then 1, 2, 3, 4, +4 here. So that's +4. And it looks like they're more than 90 degrees, but that's okay. So when you project u onto this line v, you get right here, right? Use a blue color. You get this, right? That's your projection. Now, depending on whether you want this component, which is a scalar value, or you actually want to turn that into a vector, you have 2 different objects being requested. So this is a scalar. As you can see, there's no arrow on top, right? This is a projection. As you can see, there's an arrow on top. Okay? Now, some textbooks will just not have, in textbooks, always arrows are replaced by boldface, right? So in your textbook, you'll probably see PROJ not with an arrow on top, but rather in boldface font. Okay? Some textbooks would actually just write down boldface for this guy and regular font for what PROJ is. I find that a little confusing, so I like this notation better. Now, it's not a hard question because all you have to do is just plug and chug. Okay? You just have to remember the formulas. But it would be helpful if you did know why such and such things work. So first of all, component is just this principle that if you have this length r, then an angle theta, then this side is r cosine theta. So if you want, let's say this is your u, and this is the line that you're trying to project, then this would simply be u this length, norm of u times cosine theta, and the way you calculate this is by saying that component of u onto v would be simply norm of u times cosine theta. Well, we know the formula for the cosine. We did it, right? That's u dot v divided by norm of u times norm of v, and then these two cancel, so this is the formula for the component. Now, the reason I derived it is because this is what I always do anyways. I don't memorize all of the formulas. I remember some of them, but sometimes those are just too much to memorize, so I'll just always derive it. Yes?
What is the angle theta between v and u?
So in this picture, it's like this is u and this is your v.
Okay.
In this picture, this is your angle theta. It's slightly hard to understand because it's now more than 90 degrees, but the same principle applies even if the theta is bigger than 90 degrees. Okay. And I've explained this formula before, right? Cosine theta is u dot v over norm of u times norm of v. So if you plug that in and cancel the u from top and bottom, then you get this nice formula, which is component of u in the direction of v is same as u dot v divided by the norm of v. And then you just go on and calculate. 2, 1 dotted with -3, 4 divided by square root of -3 squared plus 4 squared So you get 2 times -3, which is -6. 1 times 4 is +4. And then this is square root of 9 plus 16, which is 25. So that's going to be -2/5. Yes.
And like, could you show us like on the graph there, what are we actually measuring? Like, what is that scalar quantity?
That scalar quantity is this length with a negative because it's in the negative direction than v.
So it's in the negative direction of where like v is.
So
going.
if you measure this length, you'll see that it's exactly 2/5.
Okay.
Yeah. This length is 5, and this is 2/5. Kind of makes sense, right? 2/5 is much smaller than 5. Right? There's this small value, and the negative is there because it's going the opposite direction. Good? All right. Now, projection. What's a projection again? It's the same thing, but now we just have to turn it into vectors, okay? So I need this as a vector, which is, it needs to have magnitude 2/5, and it has to have the direction of -v. Or another way to say it would be, it's kind of wrong to say magnitude is negative because magnitude is always positive, right? Yeah. But think of it like negative magnitude in this direction, okay? Negative magnitude of -2/5. Then this is very much related to the previous question that we solved, which is if you wanted to have some arbitrary length vector in the direction of another vector, what do? You first take that direction and normalize it to a unit vector, and then multiply whatever size you want. That's the idea. Okay? So which vector are we normalizing here? For this question, which one should I normalize? I want this vector to be in which direction?
Positive.
Not, maybe, okay, V, multiple choice, U or V, which one?
V.
V, I want this to be in the V direction, right? Yeah. So which one should I normalize? V, right? Yeah. You resize this to size 1 and just multiply this value that you want, and that's it, right? So what we're going to do is we're going to take V, well, the simple answer is this, it's -2/5 times V hat. Understood? Where V hat means it's the resized version, the normalized one. Okay? But what is V hat? V hat is -3, 4 divided by square root of -3 squared plus 4 squared. Okay? V hat is V vector divided by the norm of V. Okay? Always the normalization is you divide the vector by its size so that the size becomes 1. Okay? So I'm just using it here, which now becomes -2/5, -3, 4, another 5, this is going to be another 5, and then you get, let's multiply this first. Okay? So it's going to be 6, -8, and then the denominator is 5 times 5, which is 25. Therefore, the answer is 6/25, -8/25. That's the answer.